Welcome to 2014 question A2. So the 3D graphic shows a piece of plane equipment from a science museum that includes a truncated hexagonal prism. Okay, so here we have kind of a pencil and it's been cut by something that looks like a ruler. The drawing on the right shows the incomplete projections of a similar hexagonal prism which has been cut by the oblique plane VTH. So we've got a hexagonal prism there and it's been cut by this oblique plane. An auxiliary elevation is also shown. So what they want to do in part A is complete the plan and elevation of the cut prism, because we can see here that those projections are missing. So here is an edge view of that oblique plane. So that is where it has cut all those edges. So what we're going to do, see, is this a nice 6-degree angle? It is brilliant. So what we can do is we're going to project back onto the edges of the plane. So that's been projected back for the base, for the midsection, and here we're projecting back to the top edges. And extend those across. Okay, so that will allow us to draw in those edges Okay, that's a good surface there. I'll show that there, and actually we're going to have hidden detail representing the bottom edge of that hexagonal prism. So hidden detail running across. Okay, and now we can just project those edges up into the elevation. So vertically straight up. There on the top edge, so that's 2 points up there. Here, and points in the middle. So we projected up already, and I have my base points. So here's my top surface. I'll travel to there. This is straightforward enough, it's just finding points in the elevation. Okay. And just to finish it off, hidden detail again representing the back edge here, running along. Okay, so that is part A completed, plan and elevation of the cut prism done. B, then, determine the true shape of the cut surface. So we want to find the true shape. I'm going to highlight this just to show it. So here's my cut surface, and I want to find the true shape of that. Now, a number of methods we could use to complete that. So here's my edge view of it. So what I could do is take a second auxiliary, right? So second auxiliary, x2, y2, project it out here, okay, and take my distances then from my x1, y1 back to my plan view, or take a datum, and that would make it a shorter distance. Probably would allow you not to prevent yourself from drawing all over the text there. So that would be one method, okay. But just looking at the marking scheme, I can see that they have done a robackment, okay, which is just fine as well. So what we're going to do is we are going to take that edge that we have, and we're going to rotate it so that it's resting on the horizontal plane. Okay, once it's resting on the horizontal plane, then, okay, we can find it in plan, because when we look down on top of our on our plan, if it's resting on the horizontal plane, then we're looking perpendicular to it. Okay, so let's take that rebatment. So we're batting about point HT, so that's our point view of HT. We'll take that down. Rotate that down. Then what we can do is we can project back the same angle as HT. Okay, so we rotate it back here. And then perpendicular to HT, we are going to project out. So these points will remain on HT because they're stationary there and they rotate about HT, and then the top points are there and there. Okay. So points, and there goes there. Okay, so that is the true shape of the cut surface. Okay, determined there. But like I said, there's a couple of different methods you can do that. Either way would be correct. So that's 2014 question A2.